Okay, hello everyone. Happy Friday. Hope you guys are all still doing well. Today, let's go ahead and talk about some application questions with quadratic equations in Vertex and Intercept forms. So let's go ahead and take a look. Mrs. Incredible can jump really high. She jumped from a platform and her hiding feet after X seconds is modeled by this equation right here. And this should say X, not T. Okay, so let's go ahead and first draw a picture and then find the key features and label the graph. So we have a platform that she's jumping off of. And here she is. And then here is the ground. So she's going to jump and then land on the ground. There it is. Okay, and then let's go over here to our graph, which will look very, very similar. And then let's go ahead and find the key features. Now, because this is in vertex form, we can easily find the vertex, right? So this graph is shifted to the right 4, so it'll be positive 4, and then up 180, there it is. And then I should also label the graph as well. So x-axis is seconds, and y-axis is her height in feet. So height in feet. Okay, so we got our vertex, and let's also go ahead and find where our y-intercept is, and I'll do it down here, y-intercept. How do we find that? Well, we're going to put in 0 for x, just like what we did before, plus 180. And then this you can use your calculator to find, so that's going to be -5, and that's going to be positive 16, -4 squared, plus 180. And that looks like it's going to be -80 plus 180, so 100. So our y-intercept is going to be 100. And I should also find the x-intercept as well. But since this is in vertex form, we actually don't know where the x-intercept is. So we can just go ahead and skip that for now. So let's go ahead and go down here and look at the questions. How tall is the platform? What key feature is this? Well, the platform is where she starts off. That's going to be right over here, the platform. And that we already found, it's going to be 100 feet. And what key feature is that? That's our y-intercept, as we talked about. What's the highest distance that she reached? After how many seconds did she get there? What key feature is this? And we kind of talked about that as well. So the highest distance, that's going to be our vertex. Here it is. So the highest distance will be 180 feet. After how many seconds? After 4 seconds. And then what key feature is this? That's going to be our vertex. So 180 feet after 4 seconds. And the vertex is the key feature. Okay, at 6 seconds, is she going up or down? How do you know? Okay, so let's go ahead and go back to our graph. So this point where the vertex is, that's at 4 seconds when x is 4. So at 6 seconds, it'll probably be somewhere right over here. That's when x is 6. Okay, so just by looking at the graph, we know she's going to be going down because this is after the vertex. So she'll be going down because it will be after the vertex. And then finally, find h of 3 and explain the meaning in the context. Okay, so this we've done many times before, h of 3. Let's go ahead and go back up to our equation. So then we have -5. Instead of x, we're going to plug in 3. And then -4 squared plus 180. So let's go ahead and find this. Once again, you can use your calculator. So that's -5 times -1 squared plus 180. And that looks like 175. And then explain the meaning in the context. Well, in this case, the 3 represents the x value. So when x is 3, meaning after 3 seconds, because x is how many seconds it is, after 3 seconds. And in this case, the y value represents her height in feet. So after 3 seconds, her height is 175 feet. Okay, so that's an example of an application that's in Vertex form. So now let's go ahead and look at one that's in Intercept form. So let's look at the scenario. Anna dives into a pool off a diving board. Her height can be modeled by the function f of x here, and x is the time in seconds. Okay, so let's once again draw a picture. So we're gonna have a diving board, so something like this. And here is Anna. And then she's diving into some water down here. And then her path is gonna be pretty similar to the one in the last problem. It will look something like that. So let's go over here and draw in our shape. And don't forget to label your graph. So this is in x is in seconds. And then her height, y is going to be height in meters this time. Height in meters. Okay, so let's go ahead and still look at all the key features. Now this one is in intercept form. So then this is going to give us the x-intercepts. We can set the equation equal to 0, and if we use a zero product property, we're going to get -1 and 3. So this one's going to be 3. And then if we were to continue this graph into the negative, we'll have -1. But we're not really interested in that point right now. But let's also find the y-intercept, just like before. I'll do it down here. So then let's go ahead and putting 0 for x, 0 plus 1, 0 minus 3. So then I get -5 times 1 times -3. That looks like it's going to be 15. And then we still need to find the vertex. How do we do that for intercept form? Well, we saw the past couple of days, right? If we have an intercept form, we can just take the average of our intercepts. So add them up, divided by 2. That will give us the x value of our vertex. So we know the x is going to be 1. How do we find y? Well, now we can just go ahead and plug in the x into the equation. So it'll be -5, x plus 1, and then x minus 3. So that's -5 times 2 times -2. And that looks like it's going to be 20. Okay, so there's our vertex, -1, 20. Okay, so that is all of our key features. So now let's go ahead and answer the questions. How tall is the diving board? Once again, we've already found that. That's where she starts. That's going to be 15 meters. What's the maximum height that she will reach? After how many seconds we'll reach it? And this is going to be our vertex, which we also found. Maximum height in this case is 20 meters. And then after how many seconds? After 1 second. 20 meters, 1 second. After how long will she hit the water? What key feature is this? Okay, so when she hits the water, her height will be 0 meters above ground. In other words, she'll be right here on the x-axis. So that's when x is 3. So it will be 3 seconds. And then what's the key feature? That's going to be our x-intercept. Now we do have another x-intercept over here for -1. But of course, since we're dealing with time, we can't have -1 second. So we're just going to ignore that. So we're going to have 3 seconds as our only answer here. And then at 2 seconds, will she be rising or falling? How do you know? Once again, let's go back to our graph here. So this is when x is 1 is our vertex. So then when x is 2, it will be somewhere right in the middle here. That's when x is 2. And again, because this is after the vertex, we know she will be falling. Falling because it will be after the vertex. There it is. And then lastly, find f of 1.5. So very similar to what we did before. Let's go ahead and plug in the value into the equation. So it will be -5 times x plus 1. So 1.5 plus 1. And then times x minus 3. So 1.5 minus 3. And again, for this part, you can just use your calculator. And you should end up getting 18.75. And then what does that mean in the context of the problem? So here, my x is 1.5. So an x here represents seconds. So after 1.5 seconds, and our y represents her height in meters above water. So after 1.5 seconds, Anna's height is 18.75 meters. Okay, so that is it with applications of quadratic functions in intercept form and vertex form. So please go ahead and take a look at the homework. I hope you guys have a good spring break. Please stay safe. We're not sure what's really going to happen after once spring break ends. So we'll keep you updated on that. But in the meantime, again, please stay safe and let me know if you have any questions. And I hope you have a good rest of your day.